For centuries, people have dreamed a fantastic dream. Imagine taking ordinary dull lead, then with skill and secret knowledge, transforming it into brilliant, shiny gold. This was the ultimate goal for alchemists. It was a powerful idea, wasn't it? This captivating quest fired up imaginations for hundreds of years. Gold symbolized not just wealth, but also perfection. It represented power, purity, and maybe even the secret to eternal life. Many brilliant minds dedicated their lives to this challenge, yet lead always remained stubbornly lead. What an enduring and fascinating human pursuit. Alchemy, however, was more than just a get-rich-quick scheme. It was an early form of chemistry. It was also deeply intertwined with philosophy and mysticism. In many ways, alchemists were some of the very first scientists. They experimented with different substances. They carefully observed the changes that occurred. They tried their best to understand the fundamental nature of the world around them. Their workshops were often filled with peculiar instruments, glowing furnaces and bubbling concoctions. They were on a quest for the legendary philosopher's stone. This mythical substance was believed to be the key to transmutation and eternal life. Now, let's jump forward to our modern era. Today, we have the power of science. We possess incredibly sophisticated tools and a deep understanding of the universe. We know about atoms, we know about the even smaller particles that make them up. Alchemists could only fantasize about these concepts. We can now directly study these fundamental building blocks of matter. Think about particle accelerators. They are like giant, superpowered microscopes. They allow scientists to peer into the heart of atoms. So the big question is, could modern science finally achieve what ancient alchemy never could? It's a truly exciting thought, isn't it? This brings us to CERN. CERN is a world-renowned European laboratory for particle physics. It's located near Geneva, Switzerland. Scientists there are dedicated to exploring the tiniest constituents of the universe. They accelerate particles to nearly the speed of light, then they smash these particles together. They do this to unravel the biggest mysteries of existence. And guess what? As of 2025, they've tackled that age-old alchemical challenge, turning lead into gold. Yes, it happened. Science rules, and it's pretty amazing to see such an old dream explored with modern methods. Let's delve a bit deeper into historical alchemy. This ancient practice was often veiled in secrecy and symbolism. Alchemists frequently used cryptic codes and allegorical language in their writings. This made their work difficult for outsiders to understand. They held a core belief that all matter was striving towards a state of perfection. In their view, lead was considered a base, imperfect metal. Gold, on the other hand, was the ultimate symbol of perfection and purity. Therefore, the transmutation of lead into gold was not just a physical process, it was also seen as a spiritual journey, a way to achieve enlightenment. Modern physics operates on entirely different principles. We rely on the scientific method. This means we formulate hypotheses based on observations. Then we design experiments to rigorously test these hypotheses. Our conclusions are built upon verifiable evidence and precise mathematical calculations. There's no magic involved here, folks. It's all about understanding the fundamental laws that govern the universe. We now know that elements are defined by the number of protons in their atomic nuclei. Lead atoms have 82 protons. Gold atoms have 79 protons. This difference in proton count is the absolute key to understanding transmutation. So what exactly did the brilliant scientists at CERN accomplish? They certainly didn't use smoking cauldrons or recite mystical incantations. Instead, they employed a highly sophisticated piece of equipment, a particle accelerator. Specifically, experiments at facilities like CERN's ISOLDA isotope separator online device are crucial. This type of machine can produce and accelerate beams of specific atomic nuclei with incredible precision. The scientists at CERN are world experts in manipulating these infinitesimally small particles. Their ambitious goal was to alter the number of protons within lead atoms, effectively changing the element. The technology involved is truly cutting-edge and awe-inspiring. Imagine trying to manipulate individual atoms. Then picture the even more delicate task of selectively removing exactly 3 protons from a lead atom's nucleus. This is an incredibly challenging feat. It demands immense amounts of energy. It also requires pinpoint accuracy that is almost unimaginable. The beams of particles are steered and focused by incredibly powerful magnets. Sophisticated detectors are then used to identify any new elements that are formed during these high-energy collisions. It's a truly high-tech realization of a very ancient aspiration. Science is constantly pushing boundaries. How does one actually transform one element into another? The secret lies in changing its atomic nucleus. The nucleus is the incredibly dense, tiny core at the center of every atom. This core is composed of protons and neutrons. The number of protons, known as the atomic number, is what uniquely defines an element. As we've learned, lead, chemical symbol Pb, has 82 protons in its nucleus. Our target element, gold, chemical symbol Au, possesses 79 protons. Therefore, the scientific task becomes crystal clear. To change lead into gold, we must find a way to remove precisely 3 protons from a lead atom's nucleus. At CERN, scientists achieve this by bombarding lead atoms. However, they don't just use any ordinary sample of lead. They often work with specific isotopes of lead, which are atoms of lead with a particular number of neutrons. They then fire highly energetic particles, such as protons or other ions, at these lead nuclei. You can visualize it as an extremely high-stakes game of subatomic billiards. But in this game, instead of particles merely bouncing off each other, the collision can fundamentally alter the structure of the nucleus itself. This remarkable process is known as nuclear transmutation. It's a capability that ancient alchemists could only have dreamed about. When a high-energy particle collides with a lead nucleus, several things can happen. The impact can forcefully knock out protons from the nucleus. Alternatively, the collision can transfer so much energy to the lead nucleus that it becomes highly unstable. An unstable nucleus will naturally try to reach a more stable state. It often does this by undergoing radioactive decay, which can involve spitting out various particles. If this decay process results in the lead nucleus with its 82 protons losing a net total of 3 protons, its atomic number changes from 82 to 79. And just like that, it becomes a nucleus of gold. It's crucial to understand the scale of this achievement. The quantities of gold produced through this method are incredibly, unimaginably tiny. We are literally talking about the creation of individual atoms of gold. At best, experiments might yield a few thousand gold atoms. You would need the most sensitive scientific instruments even to detect their presence. You certainly couldn't see this gold with your naked eye. So this process is not a pathway to instant riches. However, it stands as a monumental proof of a scientific principle. We can indeed transmute lead into gold, fulfilling an ancient quest through modern understanding. So, if we can't use this method to mint gold bars, why is this discovery significant? Well, experiments like these at CERN tell us a tremendous amount about particle physics. They provide invaluable insights into how atomic nuclei behave under extreme conditions. We learn more about the fundamental forces that bind matter together, such as the strong nuclear force. These kinds of transmutation experiments rigorously test our existing theories about the subatomic world. They push the very boundaries of our knowledge. Every new piece of data, no matter how small it seems, contributes to the grand puzzle of science. This is how scientific progress truly happens. This type of research also paves the way for other important studies and applications. A deeper understanding of nuclear transmutation processes can have significant benefits in various fields. For instance, in nuclear medicine, similar techniques are used to create specific radioactive isotopes. These isotopes are vital for diagnostic imaging, like PET scans, and for targeted cancer therapies. In materials science, the ability to alter elements could one day lead to the creation of entirely new materials with unique and desirable properties. The primary goal isn't just making gold, it's about gaining fundamental understanding. This understanding often leads to unexpected and wonderful breakthroughs. Pretty neat, huh? Now let's address the practical question of economics. Could we ever make a financial profit by turning lead into gold using a particle accelerator? The answer is a resounding no, not even close. The process is extraordinarily expensive. Operating a massive particle accelerator facility like those at CERN requires colossal amounts of electrical energy. The sophisticated machinery itself, the magnets, detectors, vacuum systems, is incredibly complex and costs billions of dollars to build and maintain. Furthermore, the amount of gold produced is infinitesimally small, literally atom by atom. The cost to produce even 1 gram of gold this way would astronomically exceed its market value. Therefore, while the ancient alchemist's dream of turning lead into gold has been realized, it has been fulfilled in a uniquely modern scientific context. The triumph is not one of material wealth, but of human ingenuity and knowledge. It's a testament to our relentless drive to explore, to question, and to understand the universe around us. Science has definitively shown that yes, lead can be transformed into gold. There's a certain poetic justice in this achievement. It connects us across the centuries to those early alchemists and their persistent quests, but more importantly, it highlights the incredible journey of science itself, from mystical aspirations to the precise and powerful domain of nuclear physics. What an amazing journey for humanity.